Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, everyone, my dear students. Thank you again for being here, and it's me, Dr. Azrul, speaking. I will be here to continue my lecture topic on a new and final topic, final chapter for this course called Recursion Methods. Okay, to me, this is a very short and quick chapter, and inshallah, I will try to complete this chapter within a single video only. Right, here comes the learning objective of the chapter. At the end of this chapter, you should be able to construct and demonstrate a recursive method in solving programming problems. In general, you will be given a few numbers of programming problems and examples, and some solutions by using a Java programming. From the solution, you should be able to understand and perhaps to construct your own program to solve with another type of programming problems. Okay, this is a chapter outline. Okay, a short and very quick chapter indeed. First, we will have a look at the recursive method, some of introduction, okay, and then it can be detailed to the concept and implementations. Once we have execute the implementation and understand how to provide solutions in programming problem, then we will learn and summarize the characteristics of the recursions or recursion methods. Okay, now we start with the recursive methods, some of the introductions of the recursive methods. Okay, guys, so how do you define a recursive method? Okay, a recursive method is a method that directly or indirectly invoke themselves repeatedly to perform programming process. For example, given a programming problem, regardless the scope and size of the problem, it will be a good solution if we can break the problem into successive smaller problems that are identical to the overall problem. The process of repeatedly to break this problem into smaller problem will require the recursive method. But how many times that we require to execute the program for breaking the problem into smaller problem? This is a big question. Okay, because if we are unable to control and stop the continuous repeated process, the program seems it will be executed infinitely. Okay, it is very hard for us to stop the program. All right, so how to apply or implement this recursive method? Again, there will be two cases. First, we call it as a base case, and the second, we call it as a recursive case. The recursive case is a continuous and a repeated process to solve the problem using recursion by reducing the problem to a smaller version of the original problem. By reducing the problem with each recursive call, the base case will eventually be reached and the recursion will stop. And now we look at the first example, okay, computing factorial. I believe all of you know what is a factorial, right? Okay, the following gray shaded text box shows the idea of calculating the factorial problem. Given any integer of number, the factorial is calculated by multiplying all the integer of each number in descending order. The process of reducing the big problem into smaller problem will reach to the end when the number is 0. As you can see, factorial 0 is equals to 1. So that will be the base case of the problem. According to the given Java program, you may find the recursive method implementation with if and else statement. If the program still not reach the base case, which is n equals to 0, the program will keep invoking the function as stated at the final line of the program. Okay, the following slides will explain and illustrate the factorial problem again, but this time the factorial number is start with 3. Okay, I'm sorry for that. Again. And how we are going to solve this? Okay, so it will show you a step-by-step process, and eventually this is another question or another example, a factorial 4. As you can see in this slide, we have a problem of factorial 4. The problem is break into a smaller part in descending order, or in the other word, we are shrinking the problem to reach its base case. The base case is when the factorial turns to 0. Given that factorial 0 is equals to 1, then we can update the return value for each small problem by returning the possible value in each level until we found the original problem, which the answer would be 24, as you can see here. Okay, until the step number 9. Okay, now we have another example. Write a program that will receive a positive integer number and write that number on the screen with digits going down the screen one per line. Okay, says the input integer is 1234 and the output should be produced a vertical way of 1, 2, 3, 4. As you can see in the given program, a method called write vertical with one integer argument will read and process the input repeatedly until the base case is reached. Okay, the following slides illustrates the solutions by tracing the recursive method and its calculation. Hope you can try to implement this example in your Eclipse and trace the output one by one. Okay, I'm not going to explain every single steps, and perhaps you should be able to get the output when we return all the smaller problems into the original problem. Okay. This is the third example. Call it as a Fibonacci number, as illustrated in the following table. Given Fibonacci 0 is equals to 0 and Fibonacci 1 is equals to 1, you may try to write a Java program to solve the Fibonacci problem. Try to understand the given example. But for sure, in the first place, you have to understand what is a Fibonacci number. You may try to Google to find the answer. It is a sum of the solution, as you can see the hierarchical structure of the display. Okay, and this is the final sections of the chapter called characteristic of a recursion. Generally, there are two common characteristics of a recursion. Firstly, it should contains one or more base case, which the simplest case in order to stop the recursion cycle. Okay. In order to reach the base case, recursion should be able to break a big problem into a small problems, bringing it increasingly closer to the base case until it becomes that case. To solve a problem using recursion, you should break it into sub-problems. However, if a sub-problem resembles the original problem, you can apply same approach to solve the sub-problem recursively. This sub-problem is almost the same as the original problem in nature with a smaller size. It just like seems you have a nested recursive methods here. Okay. We have another example here for a problem of printing a message. Okay, for n times. The solution is given, and please you should try to implement this, and the following slides will provide you with some more questions and exercises. Construct a Java program to solve the given problem. As you can see, as you can observe, okay, most of the example and also the questions provide you with the solutions. Okay, and perhaps you can try to understand step by step, and then you may trace how the output will be generated. Okay, until sorry, until you can find the final output. got an exercise here, another exercise, and another exercise. All right, so please do some study group and discuss with your team members, okay, on how to construct a simple program, a simple recursive method that capable to serve to provide a solutions for the given problem. With all the exercise given, we end up this recursion chapter for today, and this would wrap up all the chapters included in this course, SSK3101, which covered 9 chapters altogether. Alhamdulillah, we managed to complete the syllabus even though we are facing hard and super challenging time to run this course via online learning due to the pandemic COVID-19 situation. Thank you for having this course in this semester. I wish you all the best with your preparation, with your final exam preparation. This is Dr. Azrul. Inshallah, till we meet again in other course enrollment in the future. Okay, we end our lecture with a surah wal asr and tasbih kifarah. Wabillahi taufiq wal hidayah. Wassalamualaikum warahmatullahi wabarakatuh.